Right. So from where we left off, we had configured the first network to advertise, which is our LAN here. Right. Let's go to the second one. Let me just check just to be sure. What is our second network? We have 10.1.1.4. We are using the interface 10.1.1.5 quad 0. So with our network, I have 10.1.1.5, 10.1.1.5 quad 0. Right, correct. And the last one is 10 right here. This one is 10.1.1.1. Okay, 10.1.1.1 here. Okay, let's see with our show run and confirm our configurations. Okay, voila, those are our configurations. Those are the networks we've advertised. Right, with router number 3, let's go to router number 3. Let's use the interface OSPF configuration command instead. Right, this one. Okay, this one. So this is the third way of advertising a network. You go directly to the interface, and you configure the process ID and the area ID. So from R3, we know of this network. We are going to go to the interface 00. We're going to the interface serial 001, 010, and 011. And we're going to use the interface configuration command. Let me see. Config T. Instead of going via the router process ID, we go directly to the interfaces that are directly connected to our router. So we have interface 00. From there, the command is IP-OSPF, okay, IP-OSPF process ID, I think, IP-OSPF, the process ID 10, area 0, and that's it. We have the second one from this router, interface serial. This one is 010. Let's start with 010, 0/1/0. Right. Same command, IP-OSPF 10, area 0. Right. We go to serial 011. Same command, IP-OSPF area 0. Right. And there, our message is showing our OSPF processes going up. Right. And these are our commands, IP-OSPF 10 area 0, directly on the interface. So I think I have 3 ways that I have demonstrated here of how to configure your OSPF. 1, the network command plus the wildcard mask. Number 2, the network command plus the quad 0 wildcard mask. With the second one, you use the interface IP address. Number 3, you go directly to the interface which is directly connected to the router. Then you configure the IP-OSPF ID, process ID, and the area ID. So it seems we have configured all the necessary configurations here. Let's now play around with our show commands. So the first show command, we're going to show from R1 our neighbors. So we have, with show command, we have a command which shows you the neighbors, your OSPF neighbors. We have a command which shows you the database. The database basically shows you the topology, the whole topology, which routers are in a given topology. Then number three, the show IP route. It shows you the routing table, which routes are being chosen by your router. Right, so let's start with the neighbor. If I go to R1 and I go show IP, OSPF, show IP, OSPF, neighbor. Right, what do I have? I have 222 and 333. We know that is router 2 and router 3. And those are my neighbors if I'm R1. So we can see R1 is configured properly. If I go to the same thing on R3, show IP, OSPF neighbor. The neighbors for R3 is router 1 and router 2. And I can see from the neighbor ID here, right? Then lastly, I go to R2 and I show my neighbors. Show IP, OSPF, neighbor, router 1 and router 3. So it means we have, at least, we now know what are the neighboring routers for every given router in the OSPF network. That's a starting point. That is the neighbor table. Right, from there, let's see our database. Starting with router number 2. Right, let's look at our database, starting with router number 2. Right, we change neighbor and we have database. With the database, it shows us all the routers in the network, in the OSPF network. That shows you the whole topology of the OSPF network. So you can see from the database, we have 1, 2, 3, and those are our 3 routers. And if theory serves me well, it says the databases are the same for all routers in the network. So for router number 2, we have 1, 2, 3 proper. For router number 1, database, we have 1, 2, 3 proper. Is 132. Okay, same difference. For router number 1, let's show our database. Very important to understand these show commands. 1, 2, 3. So we have successfully added all the routers in the network. It now means every router knows every router. Therefore knows every other network connected to the router that it knows. English. I hope you understand me, boys. English, not in say, but it's proper. But basically, that's what I'm saying. So from the link, from the database, I can show every router in the network. Let's show other commands, show IP routes. This is the topology table. So I've shown you 3 tables right now. The neighbor table, showing the neighbors, the database, showing the topology table, then the with show IP route, I'm showing the routes which are being chosen, the routing table now. Show IP route, voila. This is my show IP route. And I can see I have these routes being linked as anima OI. Those are my routes being linked via OSPF. OS via OSPF C and L, those are directly connected in local networks. But focusing more on my OZI, though my networks are configured hit to advertiser, that is what we were doing. Right. Let's now go to, I think my configuration is either done. Let's check now, can we ping? Before, I think lastly, that is, what is the last thing we are going to do? The passive interface. We won't see the effect. Let's check now if from PC, which PC is this one? Why is this one not moving? Just a minute. Okay, voila. All right, from PC1, we're going to ping PC2. It should be successful because now routes ese akuzikanwa, and voila, our ping is now successful. Let's ping PC3. PC3 is just 30. It should be successful as well because my routes edu ese akuzikanwa. Voila. And basically, that is OSPF, point to point. You just advertise your network, process ID, configure the router IDs, advertise your networks. Zvimwe zvekudhipisa network inenge iri kutofunctiona zvema-hello interval kumachinja nekuchinja mabandwidth nekuchinja macost toenda kutodhipisa, but for now network iyo iri kutofunctiona with just the basics. So let this be the foundation that you can build on. Tozosvika pakuita kuchinja ma-configurations mamwe kuti ndoda kuti root randoda kuchuza nderipi for this specific network, or router richapropagata default static route nderipi, or router connected to ISP richabehava sei. For now, let this be the foundation. Network yedu yakutofunctiona, tatoconfigure routing protocol yedu OSPF. Right, done. So maybe let me just configure. We won't see the effect. Router OSPF. Let's just configure the passive interface. Config T, router OSPF 10. Router OSPF 10 is the command, right? Passive interface. So I'm on router number 3 here. If I'm looking at router number 3, the passive interface is this interface right here, this interface with the PC. There is no need for routing protocols, routing messages to be sent to this interface. For security reasons, most importantly, we configure this as a passive interface so that there are no routing messages that are sent there. Because if an intruder comes, per PC, a intruder, and listens to the routing messages, an intruder can use that information to penetrate network yedu and cause more problems. So this interface is connected to a local area network, it connected to the PC, network passive interface. So interface radio is gig. Interface gig 00. Passive interface gig Ethernet 00. That's our passive interface. So we do the same for this interface. We do the same for this interface as well. You will see you do the same for an interface connected to the ISP. Why will you want your routing protocols to go to the internet? Your routing protocol messages to go to the internet. You won't need that. Wakomana vanofambira network yako. Right, so basically that's it for point to point. Right, quickly going to, let's now branch network yedu. Instead of having this multi-access independent, let's just join them. We can do it independent, I don't know. All right, so I'm going to need my 1941s as well. Let me see, I'm going to need 3 of these. 1, 2, 3. I'm going to need a switch. Very important to understand the difference between these two. With a point-to-point network, a router is directly connected to another router. That's a point-to-point network. In simple terms, you can see this router, R3, it shares routing protocol messages with router 1. Or using this link, it shares with router 2. That is a point-to-point. It can only share with one device. So this link is used to share with R1. This link is used to share with R3. That is a point-to-point. With multi-access, it's a bit different. Watch. With multi-access, ¿qué pasa? All right. With multi-access, this is the difference. Let me just make the connections first. Do we have another giga? I hope so. Yes, we have one. All right. Let's just put a PC here, the PC here, and the PC here. Make the necessary connections. Voilà. Voilà. And voila. Right. The difference between point-to-point and multi-access, like I said, here, router 3 can only share its protocol messages with router 1 using this link. So this link is point-to-point because I'm sharing with one device only. This is different now in this network on my right. Because we have a common link, which is our switch, which we call a shared medium. It means if this router here, let me name them. So this becomes my router 4. This becomes my router 5. Let me name them for easy explaining. This becomes my router 6. Right. So if router 5 is to be configured is to be enabled with OSPF and configured as an OSPF router, it means it will need to share some messages, some protocol messages with other routers. How will it share its messages? It will share its messages via this shared medium, which is the switch. And if it's sharing via the switch, it broadcasts the message. So it means it will share with router 5, router 6, and router 3 as well. It's different from my network on my left side. There is no way router 2, okay, if I had another network, let's say if I had another router, actually we have another router. Let me see. Let's say if I had another router here and there were connections right here. Let me see if I'm able to explain this. Right, let's have another router here. Right. All of these are point to point. Right. My laptop is now screaming. Those are shared with my 8 gig RAM. We now need my 32. Right. Why is it not connecting? Okay, my ports are pair. Let me remove one port there. All right, you cannot be connected to that port. Me wanting to explain is complicating things a little bit, but let us do this. Let's remove this, or let's remove this. I can remove this and put it right here. Giga Ethernet. Right. With point to point, there is no way this router 2 can communicate with this router here on a point to point link directly because it's not broadcasting. There is no way. Router 2 can only communicate with router 1 using this link or with router 3 using this link. It's not directly connected to this one on a point-to-point basis. That's a point-to-point. With a multi-access, router 4 can communicate with router 5, router 6, even if not on a point-to-point network. How? Using this shared medium, which is our switch. So you see a broadcast is sent to this switch, then it goes to R5 and R6. R6 sends its broadcast to switch, R5 and R4 gets the messages. The problem with multi-access is explained before module 1 and module 2, concepts and configurations. The problem, the messages, I don't want this because they are being broadcasted, switch rotor or broadcast out, and we have a lot of messages being broadcast per network. So instead of having that, we have an election. One router is elected as the designated router. We have a backup designated router. Election depending on the priority values and the router IDs. By default, here my priority values edu are the same. So it means my router IDs edu will be very crucial per election. Right? So R4, R5, R6, highest router ID will be R6. So probably this one will become the designated router. So what the designated router does, every router in the network will now send its protocol messages to the designated router. They don't broadcast. They send to the designated route. Multicast broadcast. Okay, it's a multicast. They send only to the DR instead of sending a multicast. So the multicast that it sends to the DR, then DR becomes the central point. Doinos will send our broadcast to every other router in the network. So the DR is responsible for the broadcast slash multicast. Every other router, the DR other is not responsible for that. Basically, that's the difference between point-to-point and multi-access. In terms of configuration, though, nothing changes. Number one, process IDs. Let me remove this. Close the international up. Yes, 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 yes. Close it. It doesn't work. I don't want to spoil my network. Let me remove this. Let me remove this. There goes my 8 gig RAM. Crying again. Okay, I want to delete this. All right, it's gone. Right here, I had a link. Gig 00. Right, continuing. So I was saying the configurations remains the same. The configurations, you configure the process ID, you configure the router IDs, you advertise your networks, you can configure the passive interfaces as well. The election process, the moment you configure the router ID, election process and Tanga, the network chooses its designated router on its own. So where we just have to do the configurations. Let's go do the configurations. Right, starting at RF4. Let's go quickly. Okay, RF4. Right, no. Let me try to do this quickly because my time. Config terminal, router OSPF. The same instance, we're going to use the same instance 10. There must be at least one app. We did configure my interfaces again. Okay, let's go through this. Config terminal interface. What are our interfaces here? Let's keep this one on top first. Right on the side. Let's go right here. All right, my interface, I'm going to open up. Then it's 00 and it should be 01. 00 interface gig 00. What is my P address? I go back to my network. Back to my network. Can I do this? Okay, I can't. Can I do this instead? Right, my network. Okay, let me do this. My network is 40.192.168.40 for that network. And for this one is 192.168.70. So that interface is .1, 70.1, 70.2.3, and we have .4 here. So gig 00 is .1. Okay, let's go. Let me close a couple of things here. PC2, router 1, router 3, router 2. We're not using router 4. Right. IP address 192.168.70.1. Wi-Fi 255.255.0. No shut. That's our first link. The second one, let me check. All right, the second one. This one. So this link is 01. Right. Gig 01. IP address. It's not 70. What is the address? Is 40. Let's say 40.1. 40.1. So we have 70.1. We have 40.1. That becomes the network. No shot. Router number 1 down. All protocols are up. Router number 5. Go to router number 5. Keep it on top. Okay. Yeah. Enable. Feed. Device, I'm sure it's gig 0. There's 01 as well. So this is 0. Yes. This is 01. Right. Interface gig 0, 0. Gig 7. And the IP address is 70. 192.168.70.2. 5.0. Your shit. The other one is 01. The router is router number 5. So it becomes number 50.1. 50.1 255.250. No shot. That one is done. We go to router number 6. Right. CLI. No, no. Enable. Show. Big. Interface. Gig 00. Interface 00. Talk. Let's put it right here. 00, I think it's this one. It's 70.3. 70.3 IP address. 92.68. 70.3. 123. Right. 5.0. No chat. Another one. 1. Right. It's router number 6. The IP address is 160. One here. Router number 6, 60. No chat. Right. That link is up. Yes, Sarah is this link right here. On router number 3, link right away 0. Enable config terminal interface. Let's give Ethernet. This link is gig Ethernet 01. Okay. Interface gig Ethernet 01. IP address 192.168.70.4. 5.5.5.0. Right, proper, no shut. Network ADS is up. Right, network ADS is up. Right, IP address for my PC's Edu. This is number 4. So it becomes 192. Running out of time again. Can we make it? Okay, this is 6. Error. Not responding. Not responding. There goes our 8 gig now. Let's try to wait and see. Ebana. I think we can end it here. Right. This is an invalid IP address. Okay. Invalid. Okay. Invalid again. Okay. Can I put mine? 192. Thank you. 168. This router number 4 is .40.10. That is not invalid. In my default, 192.168.40.1. All right, PC, this one, PC 6 is done. Let's go to PC 5. Reconfiguration. 192.168.50.10. And this one, can copy this, paste it right there. This one is done. Then I go to PC4, router number 6, and change here, stick there. I can change here, paste, and then stick right here. Right, done. Okay. Let me check if from PC1 I can ping PC number 6 right here. I know I cannot because the multi-access network is not being configured yet, but let me just do that. Ping command prompt. Let's ping 192.168.40.10. Is it dot 40.10? 40, 50, 60. I think this is 40. PC is 40, yes. This is 50. This is 60. Okay. Let's ping the 40. This is the one we're going to use. Right. Destination host unreachable. We now know what that means. No routing configured. Right. So to configure our routing, starting with this one, I'm gonna try to do this quickly. Router OSPF10, router ID that is 4444. Right. The networks I'm going to advertise. That router is going to advertise 2 networks. This one, 192.168.40. Let me put .1 and 0. Area 0. Area 0, network 192.40.1. Right. Then the other one is 70.1. The other network 70.1. Sure. Then we go to this router here, router number 5. Okay. Fig terminal, router OSPF, and my router ID is 5555. My networks, I go directly to my network. So I have interface 192.168 dot, that's 50.1, quad 0, area 0. Let's see if another one, 192.168.70. It should be .2, .2.70. And the other one is 3. This one is done. Let's go to the last router. Let's go to the last router. Config terminal router OSPF 10. Router ID, that's number 6. That's number 66666. Directly to my networks. So we have 192.168 dot. That is router number 6, so it should be 60.1, 0.0.0, area 0. The other one is 70.3. That interface is 70.3. Right. So my networks SA are configured. Let's now check. Let's now check from router attached kwa designated router. I have 3 minutes left. So the moment you enter the router ID, pandesa router ID is election process yatoitwa. I think in the packet tracers, there's a debug process where you can see with election process, it was say, yeah, let's just assume you know there's an election process. Now let's just check with our show IP. Let's start with the neighbor. Show IP neighbor. Show IP OSPF neighbor. Right. Here, my neighbors, I'm from R6. My neighbors are R5 and R4. Right? And the difference between pama multi-axis and pama point-to-point, you can see pana pa state tane full BDR, full DR. Pangati chisa ma show neighbor kunoko. Kwangu sina zima full DR and full BDR. The reason why, obviously, linked to my point-to-point networks, Atina that election process. Right? You can see here, Atina that election process. Right? So now that it's a configure OSPF here, let me just check for connectivity before probably if I have anything else to touch on, I can touch on that. Donate network, is it up? Still destination Western reachable. What else? Something we didn't configure. Okay, this network here. Panapa at no configure this network, but router no also that network. Okay, let's go directly into the interface. IP OSPF. I hope that's it. That's 10 area 0. Okay, let's fast forward. Okay, network here. I think I guess we'll see one way in this route. And I hope this solves our problem. If it doesn't solve our problem, probably as you revise, you can try to find what's the problem with network here, why we cannot ping the other side. Okay, voila, this one is done. Right. 1 minute, 30 seconds to summarize what we've just done here. What we've done is connected network area ESA with my routers 1, 2, 3, 4, 5, 6. My networks mangana 1, 2, 3, 4. I can see 5, 6, 7, 8, 9, 10. 10 my networks AC. Tama connector using the routing protocol radio OSPF. And how we did that? Very simple. One, process ID, the router ID, you advertise my networks. The advanced commands, let me put it that way. My commands are advanced, like changing my hello intervals. Let's use this as the foundation for that. You probably won't have enough time to go through that. Those 2 more sessions ahead, I can see 1 minute left, are already done. So I think basically we have checked connectivity between this PC and this one, PC6, PC1, and PC2, meaning we have successfully configured OSPF point to point on my left, multi-access on my right. Thank you very much for giving me your time. Aleleka.